Good morning. Good morning, students. Yes. Good morning. Okay. So shall I start with the class? So we were discussing about structure of atom, right? So we were discussing about the structure of atom. Now, can anyone send me the word, concept, title, what we have discussed in the yesterday's class? Okay, structure of atom. Yes, in yesterday's class we have discussed about. Good morning everyone. Yes. Okay, Rutherford atomic model. Yes, very good. So we have discussed about, first one is Thomson. Oh, I remember. First one is Thomson's atomic model. Right? Now, Thomson's atomic model is also called as, it is also called, all of you are right. Even we have discussed about Rutherford's atomic model, very important one. So now when it comes to Thomson's, J. Thomson's atomic model, it is also called as, yes, it should be Plum, not Plump. Okay, Sneha, I think in urgency you have typed. So this is where we have the plum pudding. Very good. So this is where we have the plum pudding model, or yes, plum pudding model, or watermelon. Very good. Or watermelon. Right? So because according to this model, positive part of an atom is uniformly distributed, and negative part of the atom, they are also uniformly distributed. Okay. So once again, when I am talking about plum pudding or watermelon, so now this is called as plum pudding or watermelon because positive part is uniformly distributed and negative part it is distributed around the positive part to neutralize that one, right? So one thing in Thomson model, he considered the neutral nature of the atom, that we have to appreciate. He considered neutral nature of the atom. So, but still, anyway, we are not following this one because we know that it is not the truth or reality. Fine, but that was proposed by Thomson's model, atomic model. Now, as you people have told, next one is very important one, that is Rutherford's atomic model. Next one is related to Rutherford's atomic model. Right? Now, before going to the atomic model, what we had discussed in the last class? Rutherford's atomic model, 1 observation, 2 conclusion. Oh, very good, Gauri. Yes, absolutely correct. So when it comes to Rutherford's atomic model, first we have discussed about, also known as alpha particle scattering experiment. Yes. Now, but one thing I'll make it clear, Rohan. Rutherford's atomic model is not called as alpha particle scattering experiment. I don't know whether you have mentioned that one. I'm talking about, I think you might have written for Rutherford's experiment. Yes. So when it comes to Rutherford's atomic model, it is based on the Rutherford's experiment. It is based on the Rutherford's experiment. That's what you have written. That is alpha particle scattering experiment. Right? Don't write short form for experiment. To save the time I am writing, but in the exam you cannot write like this. So that's where we have the Rutherford's experiment, which can be called as alpha particle scattering experiment. Yeah, yesterday one question was there, right? So why they used gold foil only? Why Rutherford has used gold foil? Why not any other thing? It was a very good question. Now the answer is whatever I have told actually. It is correct only. In the last class when the people have asked the question, I told that since gold is a soft metal or it is having high malleability, so we can have the thin sheet from the gold. So therefore in this experiment we wanted as thin as possible with respect to the metal. Okay, so yes Agnesh, it is malleable, not U, E. It should be M-A-L-E-A-B-L-E, malleable. Okay, malleable. Since it is malleable, so therefore they used gold. So why we wanted malleable? That is because we wanted a thin sheet. We, in the sense, Rutherford wanted to have a thin sheet. So what I mean to tell you is, if I have a thin sheet, as in such a way that it should be of thickness where approximately one atom in one layer. Approximately one atom in one layer. Okay? So therefore he chosen gold. Okay? If I increase the thickness, what will happen? Layers of atoms will be there. Now when you pass the radiation, there can be a hindrance. So to avoid that, as thin as possible, he wanted a metal sheet, which is possible only by gold. So therefore he selected gold foil. Whatever yesterday I gave, that was correct. I wanted to say whether any other reasons are also there, but no, that will be the answer. Okay? So that's where we have the Rutherford's experiment, alpha particle scattering experiment. Now with respect to alpha particle, it can be called as alpha particle, yes Dikshit, it can be called as alpha particle or alpha radiation or alpha rays. Anything is fine. Alpha particle, alpha radiation or alpha rays. You can use any of these words. So that's where he did the experiment. Now what was the observation? Observation was most of the radiations, they were passing in a straight line. That was the observation. And some of the radiation, they were having deviation or they were getting deflected with a small angle. And when it comes to very few radiation, they were bouncing back, or I can tell deflected by 180 degree. They were bouncing back. So that's where we have the observation, or Rutherford has the observation based on his experiment. So what was the conclusion? Conclusion was, since most of the radiation they were passing in a straight line, atoms will be having lots and lots of empty spaces. That was the explanation, conclusion for that observation. They were having lots and lots of empty spaces. Now, why some of the radiations they were getting deviated or they were getting deflected? So that is because there is a presence of positive charge or positive part. Due to the presence of positive charge or positive part in a small area of the atom, right? So why very few radiations they were bouncing back? It confirmed that positive part is restricted to a small area. Positive part is restricted to a small area. So what I mean to tell here is, this experiment is disproving Thomson's atomic model, which tells that positive part is uniformly distributed, but that is discarded or disproved by the Rutherford's experiment. All of you have understood? So that's where we have the advantage or application of the, not advantage, application of the Rutherford's experiment. Okay. Now, what is that Rutherford's atomic model talks about? It tells that atomic model is similar, or structure of atom is similar to that of the solar system. It is similar to that of the solar system. So what do you mean by that? What is solar system? That is because he told that positive part is restricted to a small area which he called it as a nucleus. That means this word, nucleus word, is coined by Rutherford. Okay, it is restricted to a small area. Okay, say for example, if I take the whole Karnataka as our atom. Okay, so then in that case, our Gokulam area or half of Mysore can be the nucleus. That is the comparison between the size. Okay, size of the nucleus and size of the atom. So therefore it is restricted to a small area which is called as nucleus, and in solar system it's like a sun. Okay. Now he told that electrons will be revolving around the nucleus in a circular path called as orbit. Orbit, not orbital. Orbital we are going to discuss in the later part. So orbits, right? So that's where they are revolving around the nucleus. So therefore nucleus is the sun and protons are the planets. No, Stefan, no. You are getting confused. Not protons. Okay? It is the electrons which he compared to the planets. Okay? Say for example, I have atom. So this is where we have the neutron and proton inside the nucleus. So surrounding it we have the orbits where electrons are present. Where all these electrons are present. Okay. So now what he did is he compared this nucleus to the sun. Now where is proton? Proton is inside the nucleus. Okay. Now orbits where electrons will be revolving. He compared that one to the planets. It's not the proton, it is the electrons. Fine. Okay, done. So that's where we have the postulates for the Rutherford's atomic model. Okay, and the final one he told about the interaction between these two, positive part and negative part, because even Rutherford was knowing that atoms will be having positive and negative part, because it was all this atomic model came after the discovery of electrons and protons. So even Thomson was knowing there will be a positive and negative part, it will be equal, and even Rutherford was knowing that there will be equal amount of positive and negative part. So therefore he told that these positive and negative, they will be held together by electrostatic force. They will be held together by electrostatic force. All of you have understood? So what do you mean by electrostatic force? In physics you might be studying this one, or you might have studied. So that is, force is equal to Q1 Q2 divided by R square. So what is Q1 and Q2? Coulomb's force it is. Coulomb's equation. So Q1 Q2 is nothing but charge of those elements in which we are talking. Okay. So Q1 Q2. What is R? Distance between them. So that's where we have the electrostatic force, which is explained by the Coulomb's force. Got my point? So that's where we have Rutherford's atomic model. At the end, he told that protons and electrons, they are held together by the electrostatic force of attraction. All of you have understood? Okay? And if you see the equation, Coulomb's equation, it is same as that of the equation related to gravitational force. If you remember, it is same as that of the gravitational force. Only thing here is we are going to write it as gravitational force, where m1 m2 divided by r square, and it will be multiplied by a constant g. okay, which is multiplied by a constant called as G, gravitation constant. So that's where we have the gravitation force. So therefore, if you see all these things, it looks like it is same as that of the solar system. Rutherford's atomic model is same as that of the solar system. That's where we have the Rutherford's atomic model. All of you have understood? Any doubts? So please remember Rutherford's experiment and Rutherford's atomic model. They are all very important. Now if it is Rutherford experiment which is asked, then no need to talk about atomic model. And if atomic model is asked, no need to write about Rutherford's experiment. You should be very specific in your answer. Okay, because we are science students, where we want specific answer. Okay, fine. So now we will move to next one. This is also very important. They can ask it for 1 or 2 marks. That is limitations. That is limitations of Rutherford's atomic model. Okay, I will write limitations of Rutherford's atomic model. Okay. Or we can also call it as drawbacks. We can also call it as drawbacks of Rutherford's atomic model. Anything is fine. So this question can be asked for 1 or 2 marks. 2 marks they will ask if they are asking. Okay. So either they will ask Rutherford's atomic model or Rutherford's experiment, or they can ask write the limitations of Rutherford's atomic model, or write the drawbacks for the Rutherford's atomic model. Now, first sentence yours should be, it does not explain. It does not explain stability of the atom. Okay, it means what? It means Rutherford's atomic model. So it does not explain stability of the atom. Now all of us we know atoms are stable, right? So that's why all of us we are existing. Even I am made up of atom. My shirt, my sweater, this goggle, everything is made up of atoms. Since atoms are stable, all this class or myself or yourself, all of us we are existing, right? But Rutherford didn't talk anything about the stability of the atom. The reason why we are talking about stability, because what he told that there will be a nucleus and electrons will be revolving around the nucleus. That's what he told, right? Now we know that when a charged particle, electrons are charged, right? And even Rutherford was knowing that electrons are charged. Now when a charged particles, when they are changing their path, they should gain the acceleration. Right? They should gain the acceleration. And since these are electrons are charged particle, they can emit the radiations to nullify the acceleration. They can emit the radiation, but that is not happening. Or if it is happening, now what will happen? Each and every time electrons are losing the energy, and due to that, whether it should go away from the nucleus or it should come towards the nucleus. Any one of these two should happen. One thing, since it is gaining the acceleration, it should go away from the nucleus. Or since it is losing the energy by emitting the radiation. Okay? So now what will happen? Each time it will lose the energy and it will come near to the nucleus. And one time it will come and it will collapse with the nucleus, because negative, positive, they will be collapsed with each other. But that is happening? No, that will not happen. If that is happening, no question of existence of the atom. Now at atom will be there, after few days no atoms. That is happening? No. Atoms are stable. So that's where it was not properly explained by the Rutherford. Okay? It was not properly explained. So therefore, it does not, no need to write all these things. One sentence is enough. It does not explain the stability of the atom, because according to Rutherford, since electrons are revolving in a circular path, that means every time they are changing the direction. Every time they are changing the direction. So that's why they should gain the acceleration, since they are changing the direction. So now two things can happen. One is either electrons slowly it can move away. That's what is happening in planets, right? So all of us we know that it is expanding. That's what they are telling. Our planets are getting expanded. So same logic is applicable for atom also, because he has compared to that one to solar system. But that is happening? No, because hydrogen atom size from millions of years it is same. Sodium atomic size from millions of years it is same. So there is no increase in the atomic size of any atom. They are constant. So that tells that, and that's what Rutherford atomic model has not explained. Got my point? So next one. Okay, fine. If they are not revolving around the nucleus, if electrons are static, which is impossible, because electrons, if they are becoming non-movable, static, naturally positive and negative, they will attract. So one thing is sure, whatever Rutherford told, revolving around the nucleus, electrons will be revolving around the nucleus, that is correct. But how they are stable, that's what he has not explained. Got my point? Any doubts? Then he didn't tell about arrangement of the electrons. He didn't talk about arrangement of the electrons. How they are arranged. An atom can have more than one electron. An atom can have more than one electron. So how they are arranged. So that's what it is not explained by the Rutherford. It was not explained by the Rutherford. So that's where arrangement of the electron he has not talked about. Or we can tell that, we can use the word arrangement of electron or electronic structure. Or we can tell that he has not explained about the electronic structure of atom. Okay, so that means arrangement of electron, one and all same. Okay, fine. So these are the 2 points which will be related to limitations. Yes, okay, fine. Yes, arrangement or distribution. Yes, we can use the word, appropriate word. Distribution of the electron. How they are exactly distributed. Yes, correct. Fine. So that's where we have the 2 important points related to limitations of Rutherford's atomic model. Fine. So if it is asked for 2 marks, both the points should be written. If you write 1 point, only 1 mark will be given to you. Fine. So this is with related to Rutherford's atomic model, Rutherford's experiment, then limitations of Rutherford's atomic model. Any doubts in this? Any doubts? So in that case, I will move to the next one. Next one is hydrogen spectra, and based on the hydrogen spectrum, Bohr's atomic model has been proposed, because Rutherford's atomic model was having limitation, right? So new theory will come, new postulates will come. That's what science is, right? So same logic is applicable here also. New atomic model will be coming, until unless there is no limitation. Now, before going to the hydrogen spectra, we have to discuss something something related to radiations. We have to discuss something related to radiations. Then only you can understand atomic spectrum. Okay? Now, when I am talking about radiations or rays, okay? Now, when I am talking about alpha particles, I told we can call it as alpha particles. But when it comes to sunlight, we will not call it as sunlight particles. That is because mass. Alpha particles, they are having mass. Okay? But when it comes to these radiations, their mass is negligible. So therefore we will call them as rays or radiations. Fine? But all of us, we know that these radiations, whatever we are getting from the sun, they are all like energy packets. They are all like energy packets. All of you will agree? Right? So that's where we have the quanta. We'll call it as quanta. That is related to quantity. That is related to quantity, energy packets. Right? Now photons, we can even call it as photons. Each photons, they are having definite energy in a radiation. Each photons will have definite amount of energy in the radiations. All of you will agree? Now, if you observe, we have one word called as, related to rays only, we have one word called as electromagnetic radiation. We have one word called as electromagnetic radiations. So anyway, in detail, all these things you are going to study in your physics, but I will give overall picture of these particular terminologies. Okay? Now when I am talking about electromagnetic, in the name itself it is that there are two words which are bound together, and together we are calling it as electromagnetic. TV and radio waves. TV waves we don't have, Stefan. It's not related to waves. But radio waves, yes, it is there. Because when I am talking about television, yes, signal will be there. That's fine. But we are commonly knowing it as radio waves. Okay? Anyway, I will come to that. So when I am talking about electromagnetic radiation, we have electrical and then we have magnetic. There are two words which are combined together. So whatever sunlight we are getting, it's electromagnetic radiation, right? Discover of TV and radio by electromagnetic waves. Yes. So now, whatever sunlight we are getting, it is electromagnetic radiation. Whatever alpha rays we are getting, that is radioactive waves only, right? And whatever gamma radiation, X radiation, X-ray, we will be going, right? We should not be exposed to X-rays very often. That is a different story. All of them, they are electromagnetic radiation. X-rays, gamma rays. Then we have UV rays, visible rays, radio waves. All of them, they are comes under electromagnetic radiation because they have two components. One is electric waves. One is electric waves. And another one is magnetic waves. Another one is magnetic waves. Since two waves are combined together, okay, they will be perpendicular. One wave will be like this, another wave will be like this. They are perpendicular to each other. So that's where, what do you mean by perpendicular? So if I take this as one wave, this as one wave. In a ocean, waves will be coming, right? So same way, this is one wave. We will consider this one as electric waves. Then we have magnetic waves. It will be moving like this, in this like this. So that's where they will be moving like this. Okay, they will be perpendicular. Yes, 90 degree to each other. So together, since they are there, that's why they are called as electromagnetic radiation or electromagnetic waves. Okay? So therefore, when I am talking about all these things, they should have the energy. These radiation should have the energy, and they have the energy. So that's where all this life exists on the earth. Because all of us, we know, whatever plants are there, they will take the energy of the sunlight. By utilizing that energy, they can produce the molecules. They can synthesize the molecule. Right? All of you will agree with that. If there is no sun rays, we will imagine we have blocked the sunlight to the whole earth. What will happen? There is no existence of life on this earth. That shows that for all of us, energy is required. From where that energy is coming? One of the sources, sunlight. So that shows that all these energy packets, that's why based on this they told that all these radiation, they are having packets, energy packets, right? And the equation for that one is E is equal to H nu, not V, nu. E is equal to H nu, right? Yes, Rohan, all of us, we are very much dependent on the sun. See, once again, chemistry. Why sun is releasing the energy? That is because of the fusion, not fission, fusion, right? So that's where those energy which will come to the earth, and all these lives, they are exist on the earth because of those energy. Okay? So what is that equation? Energy, E is equal to H nu. H is a constant. Okay, H is a constant. So E is equal to H nu, where nu is nothing but frequency. Nu is nothing but frequency. Okay, this is one equation. It is important. E is equal to H nu. Now we have another equation. We have another equation where nu is equal to C by lambda. Nu is equal to C by lambda. So what do you mean by lambda? Yes, Rohan, you are absolutely right. Okay, two atoms will be combined to form the larger atoms. Energy will be released because E is equal to mc square, right? As there is a change in mass, energy should be released, right? So E is equal to H nu, nu is equal to C by lambda, where lambda is, yes, wavelength, where lambda is wavelength. Fine. So that's where we have the two important equations. Okay. Now, anyway, I will explain it briefly. So I have 2 points, and this is the axis. Okay. So now we have a waves. We have a waves. So this is one wave. Okay. Now I will keep the distance same. Okay. I will keep the distance same, means length same. Now I have another wave. Right? Now what is happening? Imagine that this height is same. Okay? So imagine that this height, amplitude are not changed. Okay, if you observe in first case, there are lots and lots of waves which are fitted into that particular region. But when it comes to second case, very less waves are fitted into that particular region. That means frequency is high in this case and frequency is low in this case. All of you will agree? Frequency is high. Oh yes, Stephen, very good. Frequency of A is more. Okay, I'll keep the name A and B. Frequency of A is high and frequency of B is low. Why? What is happening? Why it is low? That is because distance, length is getting increased. Distance between troughs or crests, it is getting increased. It is low here, less distance. It is less distance. So that means When I am talking about the length, I am talking about the wavelength. I am talking about the wavelength. Now I can tell that B has, yes Rohan, B has greater wavelength or larger wavelength and A has less wavelength. Fine. So that's where frequency, number of cycles per second, number of cycles per second. Okay. So that's where we have the frequency, cycles per second. Okay. But when it comes to wavelength, unit is different. It is a length. It is a length. Got my point? So what is frequency? Frequency is nothing but number of cycles per second. Number of cycles per second. Okay? So which can be expressed in terms of hertz, Hz. Which can be expressed in terms of hertz. Right? That's for frequency. But when it comes to wavelength, it is the length or distance between crefts or troughs. So naturally the SI unit, since I am talking about the distance or length, it should be meter or nanometer, which can be derivatives of meter only, right? Yes, Rohan. That's where we have the different units for frequency and wavelength. All of you got my point? So cycles per second, from here it has started, come back in here only. Okay, here it has started, come back into the same point. That means 1 cycle per second. So that means, as the equation tells, frequency and wavelength, they are inversely related to each other. Frequency and wavelength, they are inversely related to each other. C is constant, that is speed of light in vacuum. Okay, that is 3 into 10 to the power of 8 meter per second. C, that is no need to worry. But we are focusing on nu and lambda. Nu is frequency, lambda is wavelength. Nu is here and lambda is in the denominator. Therefore, they are inversely related to each other. That's what we can see here. As there is an increase in the frequency, there is a decrease in the wavelength. As there is a decrease in the frequency, there is an increase in the wavelength. That's what they are inversely related to each other. What about energy? Energy and frequency, they are directly related to each other. That means A is having higher energy compared to B. A is having higher energy compared to B. That's what we can conclude, because in A, frequency is high, so naturally energy should also be high, because they are directly related to each other. All of you have understood? Now in that case, can some of you tell me, what is the relation between energy and wavelength? What is the relation between energy and wavelength? Energy and frequency I told. What about energy and wavelength? What is the relation between energy and wavelength? Any one of you? Energy and frequency, yes. Okay. Natasha, okay, very good. Energy and wavelength, they should be inversely related to each other. What is the reason? Because since energy and frequency, they are directly related to each other, and frequency and wavelengths, they are inversely related to each other. Naturally, even energy and wavelength should be inversely. No, Rohan. No. Wavelength and energy, they are inversely proportional. They are inversely proportional. That's what we can see here. I told in case of A, since frequency is high, energy is also high. But what is happening to the wavelength? It is becoming less. So that means since energy and frequency, since they are directly related to each other, naturally energy and wavelength, they should be inversely related to each other. So as there is an increase in the wavelength, it should decrease the energy of the radiation. All of you have understood? Yes, they are inversely proportional. Fine. So that's where we have the equations. Okay, that's where we have the equations. Any doubts? Any doubts? Okay. Now we have a prism, and we know that if there is a sunlight, when rain is there, if there is a sunlight, what we'll observe? We'll observe the rainbow. Right? We will observe the rainbow. Why rainbow will be formed? That is due to the diffraction of the light, due to the water droplets. Each water droplet will behave as a prism. It will act as a prism. Same logic. So when we pass the light, now what will happen? Since one and another one are there, now what will happen? They will be split into, they will be split into different wavelengths of radiation. They will be split into different wavelengths of the radiations. So that's what we can observe. So this is due to diffraction. The phenomena is called as diffraction. Okay, na? So this is due to the diffraction of light. Okay. Now what will happening? Whatever spectrum, yes, dispersion of light, yes. So whatever spectrum we are going to get, that is called as continuous spectrum. That is called as continuous spectrum. Okay. Why we will call it as continuous spectrum? Okay, something board, something I saw. Okay, band. I thought it's board. Okay. Yes, it is Wavelength. Yes, it is Wavelength. So together we can call it as visible light or rays. Together we can call it as visible rays because we can see. Therefore we can call it as visible rays. Got my point? Now, if you are having some problem in your teeth, okay? So if you are going for X-rays, we should not go for X-rays very often. Once again I am telling. But whenever we are exposed to the X-rays, we cannot see. X-rays we cannot see. Okay? But here we can see the colors. It's visible. Therefore they are called as visible radiation or visible rays. X-rays, electromagnetic radiation, even visible rays belongs to electromagnetic radiation only. Got my point? So due to the diffraction or due to the dispersion of light, there will be formation of continuous spectrum. They are called as continuous spectrum because after violet, indigo colors, they are merged with each other in the border. So with your indigo, blue and all, they are merged with each other. Okay? So there is no gap. Okay? They are continuous. So they are merged with each other. When you are seeing the rainbow, whether we can tell, okay, that yellow, it is completely separated from another color. No. Slightly they will be merging. Right? So therefore, in short, they will tell that this one as a blue region of visible spectra and this one as a red region of the visible spectra. Broadly, we can classify visible radiation as blue radiation and red radiation. Broadly. Okay? So this is where individually we can mention. All of you have understood? So therefore, they are called as continuous spectra because there is no clear demarcation. They are continuous. They are continuous with respect to each other. So therefore, they are called as continuous spectrum. What do you mean by spectra? Spectra means where this energy has been separated. That's why they are called as spectra. So continuous spectra. So continuous spectra will be formed due to the diffraction of radiation. When a sunlight will pass through a prism or any light when passed through a prism, There will be diffraction of light. So dispersion will happen. So that's where we are going to get the continuous spectra. All of you have understood? Now if you observe this one, okay, if you observe this one, whichever comes on the left hand side, they will be having shorter wavelength. Whichever comes on the right hand side, there will be increase in the wavelength. Observe it carefully. What I mean to tell you is, on the leftward if you move, wavelength is going to decrease. On the rightward if you move, exact opposite, naturally, wavelength is going to increase. In that case, can you tell me? Yes, water droplets will act as a prism. Yes, Yagnesh, absolutely right. Okay? Shorter wavelength and higher, absolutely correct, Rakesh. So, in that case, can any one of you tell me, among the visible spectrum, blue region and red regions are there, which will be of higher energy? Blue region or red region? I have shown the wavelengths. Leftward if you move, wavelengths are going to decrease. Rightward, wavelengths are going to increase. Yagnesh, I am asking which one will be of higher energy? Red region or blue region? All of you will agree? Oh, many of you have written red region is having higher energy. Whether it's correct? No, now I am getting the answer. It's blue region. Blue region should be of higher energy. Please remember, wavelength is decreasing. When you come to leftward, since there is a decrease in the wavelength, energy should increase. All of you have understood? So that is because we have E is equal to H nu, and then we have nu is equal to C by lambda. Then we have E is equal to 1 by lambda. So according to that, frequency and energy, they are directly related, but wavelength and energy, they are inversely related. Don't get confused. So therefore, blue region will have the higher energy because there is a decrease in the wavelength. Energy should increase. Red region will be having lower energy. That is because wavelength is getting increased. So energy should decrease. All of you have understood? Don't get confused. You want me to explain once again, or all of you have understood? So it should be blue region is the one which will be having higher energy. Okay, done. So this is related to continuous spectrum. Okay. So now, when I move to the next one, hydrogen spectra. When you move to the hydrogen spectrum, which is one of the important concepts for your examination point of view. It is one of the important concept. So that is, hydrogen spectra is considered as a line spectra. Is considered as a line spectra. Right? So what do you mean by line spectra then? We know continuous spectra. What do you mean by line spectra? So line spectra means there will be clear demarcation between the different energies. There will be clear demarcation. So that's why they are called as line spectra. So please remember, hydrogen spectra, if you are asking, if you have a question on that, first sentence should be, it is a line spectra. Okay. Now, when I am talking about an atom, okay. So now we have the nucleus in the center, no doubt. We have the nucleus in the center, even which was proposed by Rutherford. Then we have the electrons. So we have the electrons. Okay. Now, what will happen whenever we are passing the radiation or we are providing the energy? I will write it as H nu. Light or H nu, because light is made up of energy packets. What do you mean by energy? E is equal to h nu. So therefore, either you can write it as light or h nu, like energy packets. Okay? So I have supplied the light. Now what will happen? These electrons, whichever is exposed to the energy, now they are going to gain the energy. They are going to gain the energy. Now due to that, depending on the amount of energy given to them, now they will be moving to the higher energy. They will be moving to the higher energy. What my point? Now please remember, we have two words. One is excited and another one is ground state. Excited state and ground state. But my point, now energy is supplied to the electron. Now electrons will be going for excited state. Electrons will go to the higher energy. It will go to the excited state when they are gaining the energy. When there is a supply of the energy, they will go to the excited or higher energy state. Okay? Now, naturally, depending on the electron arrangement or depending on the distribution of electron in an atom, those atoms will absorb or those atoms will take up specific amount of energy only. All of you will agree? Now all of us will know that each atoms, they are having their own set of electrons. Each atom, they are having their own atomic number. Okay, I will first talk about atomic number. Okay? Now, what do you mean by atomic number? Atomic number is nothing but number of protons present in a nucleus. Atomic number is nothing but number of protons present in the nucleus of an atom. Right? So that's where we can define the atomic number. Number of protons present in the nucleus of an atom. That is nothing but atomic number. Now, yesterday only I have told, if I take any of the atom, if I take sodium as an atom, Rohan, I will come to that. So what is the atomic number of sodium? It is 11. That means sodium is having 11 protons in its nucleus. Sodium is having 11 protons in its nucleus. Now, whether sodium as an atom is having any charge? No charge. Sodium without any charge, it's understood that it is neutral. So therefore, even it should have the 11 electron. Now, if you want to talk about the electron with respect to atomic number, then you should mention that number of electrons present in the atom, in the neutral atom. That is important. Okay? Atomic number is number of protons present in the nucleus. Done. Or it can be number of electrons present in the neutral atom. That's very important. Why? I will explain it now. If I take or if I remove one electron, now it became Na plus, sodium ion. What is the atomic number of sodium ion? Anyone? What is the atomic number of sodium ion? Na plus. Sodium, it is 11. What should be the atomic number of Na plus, sodium ion? 1 electron is removed. So 1 proton is remaining there. 11 proton, 10 electron. Now Rohan, that's where the confusion is. Atomic number of sodium plus is 11 only. It is 11 only. There is no change in the atomic number. Please remember. So therefore, what it tells definition? Number of protons present in the nucleus of an atom. Done. But when I am talking about electron, I am mentioning that in a neutral atom. I have mentioned it as neutral atom. Okay? But when I am talking about sodium, it is 11 proton, 11 electron, no doubt. It is 11 proton and 11 electron. But when I am talking about sodium ion, it is 11 proton and 10 electrons. It is 11 proton and 10 electrons. But still, atomic number of Na plus will be 11 only. Atomic number of Na plus will be 11 only, although there is a decrease in the number of electrons. So therefore, if I want to mention in terms of number of electron, I should mention the word neutral atom or neutral condition. Fine? So that's where we have the atomic number. Okay? All of you have understood? Now, when I am talking about mass number, when I am talking about the mass number, atomic number representation is Z. Atomic number representation is Z. And mass number representation can be A. Mass number representation can be A. Okay? So mass number is nothing but number of, okay, you should tell me where the mass of an atom is present, in its nucleus or in its electron. Any one of you? Mass of an atom, where they are present or concentrated, in the nucleus or in the atom, means electrons. Yes, it should be in the nucleus. It should be in the nucleus. That's what, if you recollect, in the beginning of atomic structure, I have told mass of the electron is negligible. We will consider it as a 0. But number of mass of proton and neutron we have considered it as 1. Okay? Stephen, it should be 0. Electron should be 0. But other case it is 1. So therefore mass of the atom, that is mass number, is nothing but number of neutron plus number of protons present in the nucleus. Number of neutron plus number of protons present in the nucleus. All of you have understood? So therefore I can mention A is equal to Z plus N, where capital N talks about number of neutron. Capital N talks about number of neutron. Z is atomic number. Z is atomic number. Got my point? So that's where I have the mass number. Mass number is N plus proton, that means small n, that is number of neutron plus number of protons present in the nucleus. So that's where we have the mass number of an atom. Okay? So therefore formula I can use, where mass number A is equal to Z atomic number, because number of proton is atomic number plus number of neutron. Together it will be considered as mass number. All of you have understood? Anyway, don't worry, I will stop here. Okay, any doubts related to wavelength and frequency? So tomorrow we are going to continue. I didn't see the time. But any doubts? Wavelength, frequency, then energy of a radiation, electromagnetic spectra. So now we had entered into hydrogen spectrum. Very, very important one. You can expect even problems in your competitive exam on hydrogen spectrum. Any doubts? Okay, in that case, I will stop here. Thank you. Take care. Okay? Bye. Thank you.